Perfect. Thank you. Thank you, everybody, for joining us today here at this virtual program that was put together by Ben Rayner and our friends from Kelar Pacific. We have Chuck Keeley here and Arian. Arian, I cannot pronounce your last name, so I'm not going to
Sunny
Khatam. Hey, hi. My name is MJ Carrion, and I am the programs manager here for AIA San Diego. For those who don't know, AIA San Diego is a chapter of the American Institute of Architects, and it's headquartered in Washington, D.C., and it was founded in 1857, and it represents about 96,000 architects nationwide with representatives across the world. Our chapter was founded back in 1928, and we pride ourselves on professional excellence, integrity, community service, and lifelong learning. The local chapter is a professional association representing about 1,200 architects across all of San Diego County. The organization is led by a diverse and volunteer board of directors representing architectural firms of all shapes and sizes, from global firms to sole practitioners and everything in between, plus representatives from our schools, from our accredited schools of architecture, New School and Woodbury. Again, thank you everybody for joining us today. I do have everybody muted, so we're gonna leave the questions for the end while Chuck and Arian do the presentation. And I'm gonna pass it on to Ben, our TAP guru. He heads up our AIA San Diego TAP committee. Ben, the floor is yours.
Thank you. So yeah, making sure I'm not on mute. So yeah, my name is Ben Renier, and I head up the AIA Technology and Practice Committee in the San Diego region. Our knowledge committee, we're as the name suggests, we're try to act as a resource for the community for areas around technology and practice. So that runs the full gamut from BIM to VR to stuff in the field, and as Kelar is a very active participant in providing knowledge to our group. So today they're here to present on the use of point clouds in reality capture, and I will just hand this right off to you, Chuck and Arian, and I'll turn off my camera and I'll listen in and learn some things like everyone else.
Okay. Yeah. Thanks for the introduction. We're proud to be part of the AA, and we love being part of the TAP program. So we're going to also turn off our program. So I'm Chuck, this is Arian, and this is Behzad. So all three of us are going to be presenting. Behzad's going to come in at the tail end to show an actual project. We've got a bunch of videos that we're going to share, and unfortunately some boring PowerPoint. So let's turn off the video and let's get going. All right, next slide. Why isn't it going?
Yeah, always gonna have some kind of issue, right? There you go.
All right, so here's the agenda. We're gonna do a quick 3D scanning introduction. Then we're gonna get into the kind of the techie part, the using point clouds with BIM. We're gonna show a couple of project examples, and then hopefully we've got some leftover time for frequently asked questions, or actually real questions. Yeah. And in that case, I think MJ mentioned that if you have questions, you can put them in you can write them in the pane. And then maybe Ben can help us moderate those questions at the end. All right. If you don't know Kelar, we've been around for 40 years. We're an Autodesk dealer, and about 15 years ago, we started doing services with the software, the same software that you guys use and we sell and we teach, and that's how we got our expertise in scanning, by the way. Mm-hmm. We do a bunch of BIM services, and reality capture is one of them. That's what we're going to be focusing on today. All right, so we're going to have a little fun. We're going to assume that you guys have a project, right? Yay! But you have no existing drawings. Do you ever run into that? Or you have really old drawings and you don't trust them. Or maybe the project's super complex, whether you have drawings or not, and you want to go field verify. And you're not just going to create AutoCAD drawings, you're going to create a 3D Revit model as-built to start with. How are you going to do that? Hopefully you're not doing this.
This is an old method, or some people still do it, but I can measure all different window, the edge of the building to a window, and you basically just sketch out what you got, and then you convert that to CAD. This process takes a very long time, and it can be exhausting both on the field and once you get back and you try to put it in CAD, it's can be a lot of time consuming. Or you can do with LiDAR, and you basically go there with this scanner, scan the building, and you convert it. So here we have this whole map of what basically happens. We have the building, go there, scan, create this scan file, put it into Revit, model it, and then generate floor plans,
Elevations, etc. So which one's better? I guess it would really depend on the project. I mean, maybe the old school method would work, but for certainly larger projects, complex projects, I just don't know how you do it without a laser scanner, to be quite honest. All right, so let's talk about the different types of reality capture. So we're going to focusing on LiDAR scanning today, but there are other technologies out there using, photogrammetry, for example, like a drone or Matterport. Certainly with the COVID situation, like all of the real estate houses and real estate using Matterport a lot. It's 3D. Looks a lot like LiDAR, but it's not. The big difference that I want to highlight is the accuracy. So LiDAR, super accuracy, plus or minus 2 millimeters, and that's with a 10 meter, that's 30 feet radius scan, so it's 60 feet.
In all directions.
Yeah, in all directions. Drones, drones cover a lot of ground quickly, but we're talking about plus or minus 2 centimeters or even more. Matterport, for example, is plus or minus 10 centimeters or 1.2 inches and 10 feet. So if you need something super accurate, we recommend LiDAR. So what is LiDAR? It stands for light, action, and ranging. Basically, you got the scanner, it throws a laser, it hits the surface, it bounces back, and then it does all this like amazing math. You don't even have to think about it.
Arian, we're not catching your mic very well.
I'm gonna get closer.
Yeah,
For the
good,
sake
thanks.
of time, this is what basically it does.
The three dominant scanner manufacturers out there today are Faro, Leica, and Trimble. We use Faro and Leica, depending on which one is the best fit for a project.
Mhm.
What else do you need to know about LiDAR scanning? First of all, it's a class 1 laser, so it's non-damaging. We get a lot of questions from customers. Hey, you're going to scan this mall. People might be walking by. Is anybody in danger? No. The other thing is they can scan in black and white or color.
Yes, and with a black and white scan, you have speed, but you lose some level of detail. If you have the color, you get that detail. If you want to know what kind of material something's made out of, I mean, you could look at it in the black and white. It's grayscale, kind of like an old black and white movie. So you won't be able to know the material very well. But if you do it in color, you can figure out everything. It's great for when you do MEP, above the ceiling kind of work, and you see a lot of ducts and pipes and conduits. It helps you figure out what kind of pipe it is.
We're going to show you some examples of both that you can see. The other thing is there's high-end scanners, this Leica, this RTC 360 that you see on the screen, that's an $80,000 scanner. And then there's low-end scanners like that BLK 360, 20,000 versus 50 to 100,000. So if you're going to buy it yourself,
It's pricey. That's just the scanner. That's not including the software.
So how does it really work in the field? How does the process work?
Well, so we take the scanner, we go to the location, we scan however many scans we need. The bigger the project, the more complex, the more rooms, the longer we're going to need to be there, the more scans we need to take. Then when we go to we take that to the computer, we open up whatever software we need for that scanner. We put all the scans in, we register them, or as we say, we stitch them together. Just basically take all the individual points, put them together. Then we export out a unified point cloud. This unified point cloud can be imported into various softwares. In the case here, we can talk about here is Edgewise, which if you use a file type, which we'll get into, that you can use, it can automatically generate pipes for you and various other things as well. But this really helps with pipes, or you can just take it straight into Revit and basically use the scan to trace everything you need to model. So as you can see here, we then create this 3D model, and from there we can create our Revit and AutoCAD drawings.
So when customers or potential customers are talking to us, they always ask, well, what do I get? If I hire you, what are the things? Multiple types of classification.
We're losing you guys again on the mic. Sorry.
Yeah, you gotta stick
I need
close
to pass
to
it back and forth.
Okay.
Jumping around a bit.
So there's viewing and measuring files, and then the optional file delivery is if somebody wants to convert those scan files to a Revit model or an AutoCAD drawing. So speaking of file types, like
there is a lot of file types you can use for point clouds. Various different companies who some have their own file types. Leica has, for instance, it's LGS. Faro uses FLS. Trimble E57. There's a lot that you can use, but there are three that are basically going to be the ones that you're going to use the most. But well, two specifically. E57 is what you can use for the Edgewise program, but the two we're mainly going to focus on is the RCP and RCS, as that's what is accepted by Revit. It's the both, and you can get these from the Autodesk Recap software, which comes with the AEC collection that you will have if you own Revit. Yeah.
All right. So we want to show you what a point cloud looks like, right? And so we're going to take advantage of the viewers that we mentioned. So there's on the desktop viewers, where we email you a huge file, and then you have an executable for something like a jet stream. Or there's on the web, and we're going to show you both right now. All right. Okay. So this is a project at Children's Rady Hospital. You can see that this is these are pictures. So if you don't know, the first go around of the laser scanner, it scans in black and white. If somebody wants color, the scanner will go around a second time and take HDR pictures, and then what it does is it maps those RGB values from the pictures into the point cloud. So now you have a colorized point cloud. So within this tool, you can do a lot of things, and Arian's the expert.
Yeah, you can, for instance, you can take measurements. This will help us if you want to find details, like if you want to know where an outlet is specifically, or how wide a window is. You can use it for many different reasons, but a big portion of it will be helping you with figuring out the finer details. If you're looking for a project, let's say LOD 300 or 350, you're going to want a viewing tool for sure.
So each of those little triangles that you saw,
those are the different views. Those are where every time we take a scan, that's what those triangles are. They're telling you this is where the scan was taken. You can click on it and go straight to that view. And here we are, and you can also just fly through the scan. Once you put it all together, you can freely move around in it. And in this room here, you can see just what level of detail you'll get with the scanner. It looks almost spot on, right? Like look at that. The pipe, you can see, you can even almost read what it says on the pipe. And we'll get closer, and you will actually be able to read it with how much detail you get. These are pretty high resolution cameras. And they do even adjust to different light settings as well. So you don't have to worry about it being too dark in certain areas. So yeah, here, if you take a look, you can even read right here, low pressure steam. It gets a little fuzzy when you get too close, but you can see. And the other thing we want to show you in this view is just how it looks like above the ceiling. Chuck, do you want to up us here? Where's the mouse is on this side? You gotta bring it over there. There you go.
I want to add something here.
Oh, that's not
A lot of times you go to the job site 3-4 times to capture the dimension that you needed, and when you do the LiDAR scan, it's one time. So you kind of one time bothering the client, not too many times.
Yeah.
So I wanted to show you this video because we actually scanned above the ceiling. Scanning above the ceiling, it's a little bit more complex. In this case, this is an operating hospital corridor. We had to move the axe ceiling tiles out of the way. You need to take a scan like below the ceiling, right at the ceiling, and then above the ceiling. And then in this particular case, we wanted to capture the mechanical, electrical, plumbing. Scanners are like flashlights. It doesn't go through metal or walls. So if you want to capture a duct conduits, you have to scan on both sides of it. So you can see the triangles are where the scanner head locations were. We're kind of weaving back and forth the left and the right of the corridor so that we capture all the mechanical, electrical, plumbing.
It is, but if you want to the ceiling, this is the best. You'll get laser precision accuracy down to 2 millimeters. It is a fantastic way to get just precise area. I mean, the pipe circumference, the length of the pipe. I don't know how we manually measured them previously, but and here we actually have a Revit file in Navisworks actually.
Yeah, so on this particular project, the GC was our customer. They hired us to scan the existing conditions. At first, they wanted us to turn the point cloud into a Revit model, but in actuality, after we showed them the point cloud and how it would interact really well in a clash process with Navisworks, we just used a point cloud for clash detection and coordination. All right. All right, moving on.
So in case you're wondering what it looks like in black, we have this
Mike again, sorry. No need Mike, please.
All right.
Is it down here?
No, it's you can see it up there. Hold on. Never mind. Anyway, so you can see here it's how the black and white looks. It's not, you don't get as much detail in terms of what you can see. You can obviously see different changes, like for instance in the wood you can kind of see the pattern, but I always found that it takes a little bit longer to look at to be able to figure out where I am exactly or what I'm looking at. This view here, the intensity basically tells you how many overlapping points there are. It just kind of defaults to it, but you can switch back to that grayscale. It should be one of the options up here. Hold on. There we go. There we go. Grayscale. So this is what it will look like if you want to freely fly around. And in this view, you can still take measurements. You can still look around everything. It's just not as pretty to look at and kind of, I don't know, a little bit harder on the eyes, I think.
So depending on what you're really trying to capture, if it's just architectural elements, walls, windows, doors, floors, soffits, exposed structural elements, black and white might do the case. But if it's mechanical, electrical, plumbing, difficult piping systems, definitely color helps. All right, next one.
Oh, this is another viewer. The other one we showed you was for the Leica scanners. This is the Faro Scene to Go. This is for Faro scanners. This is something that you can just simply export out of Scene, which is the Faro proprietary software for scanning, and you can basically just send it to a client or whoever's modeling and just be like, here's a viewer. It's a very basic viewing software. You don't get as much depth with it. You may notice there's some empty gaps here when we switch to the cloud view. Those are points that I ended up deleting. You can't get that overlapping view in this, but it is a nice quick view that you can show to clients, or if you want to just get that detail, you can still get that level of detail from modeling. And there is a better option available for Faro scanners, and we'll show you that here. Actually, we have a video for it, but I think it might be better to
Let's pop out.
We'll pop out here. Did we ever? We never. Okay. Give us a second here. Hold on a second. Can you see the screen? Ben, are you able to see the screen?
Not yet. No.
Okay. Okay, hold on a second. Can you grab me my headset? Hold on. Oh, hold on. Never mind for the video. Hold on. Yeah. I just had to show the video. Here. Yep. All right, here's one. I'm gonna fix the audio problem here. Okay.
Run the video and forget it. Yep. Guys, we're just gonna run the video instead of doing that live.
Perfect. Yeah. Give me, where's the, hold on, where's the Zoom? There it is. Hold on. Hello, Ben, can you hear us?
We
All
can
right.
hear you.
Is that much better?
Yeah, we can hear you pretty clear.
All right, good. I wanted to make sure. Get this out of my site. And where is, there we go. I'm trying to get us into presentation here. Share screens.
Oh, we're seeing your the presenter view.
There you go.
Wrong
How
screen.
about now? Can you hear me
That's
now?
great.
That's good.
There you
Yep.
go. Thank you. All right, cool. So we're just gonna play the video here. So now you can see it looks very similar, but there are a few differences. For instance, now when you go into the 3D view, you'll notice that it looks kind of like how the Jetstream viewer looked. You can fly around, you can look around, you can fly around, you can take measurements. It's a lot easier to see. You can go into each one of those views like you saw before. And you'll notice that we have a lot more options here. You can make, and this is something that you can easily just get a link of, kind of like a Google Drive, and just send it to a client or someone who's working on the project, and they can have access to this. They can also export an RCP or an RCS from this file. They can take measurements, they can make anecdotes, they can basically share information with other people working on the project, attach links, add links, attach files, edit it in various ways, create section boxes, clipping boxes. And this also allows you as a project manager to have more control. As you can see right here, you'll see that you can add different users. You can manage a group of people to work in specific areas of the project. So it gives you a lot of options in order to properly manage a team working on a Revit model based off the scan. Next one.
All right, now we're going to get into the real technical stuff, using point clouds with BIM, and in our case, it's Revit. It's really working with Revit. All right. So we mentioned two file types that work well with Revit. It's really your only two import options for Revit, and it's RCS and an RCP. Why don't you explain the difference?
All right. Well, so an RCS is generally one scan file. When you go out and you take a scan, you generate whatever the proprietary hardware's scan file is. That would be FLS, for instance. Once you bring those scans into Scene, they are converted into, or not Scene, into a recap. They are converted into a recap scan, an RCS. If you have multiple scan files in there, once you import a scan project where you're able to stitch together the scans or modify, clean up, create sections, you can actually use it as a viewer if you want to. So when it comes down, and we're going to show you what the best to use for Revit. When it comes to which one should you use for Revit, it's best to use an RCS. And the reason is because it's all unified into one project. If you're going to, if you use an RCP, the RCP file itself is actually really small, a few kilobytes or megabytes. but it requires the use of a support folder where it stores all the data that it's actually going to use. For this reason, when you want to use a scan file in Revit, using an RCS, you'll have a direct line of communication with that file. So that way it's able to refresh a lot quicker when you move the viewer. If you use an RCP, it has to send the request to see what the file is looking like to the RCP, which then goes into the folder, finds the RCS that's connected to that, sends that data back to the RCP and then back to Revit. So this will actually slow down your ability to work in Revit with a scan file. So what you want to use at all times is an RCS.
All right, I told you it was gonna get technical.
It's about to get technical here, so but
right.
bear with us here.
All right, so how do you get point clouds into Revit?
Well, so you have three options. You have center to center, which is best for when there's no existing model. Basically, it just kind of guesses where the middle of the scan is, and it just drops that right into Revit, right at what Revit considers the origin. You have origin to origin, which is best for lining up with existing models. This is for if you have a model that you've been working on or have previously used, or you're in the middle of a project and you want to update to see how the project's going along and how construction is going along. This is what you'll use it for. You'll try to orient the scan with the model, and then you'll do this, and then you'll have to set the origin to be the exact same as it is with your model. So that way, when you bring it in origin to origin, the scan file should land right on top of your model, perfectly oriented, everything lined up as they should be. And then, but if you're lucky and you have a survey points or shared coordinates already published from Revit, you can use that in your point cloud, and that's when you can use the by shared coordinates option. It will fall right into place using these coordinates.
All right. So many times we'll scan, we'll create a unified point cloud. We'll create those RCPs and RCSs, and then we'll send it to the customer, and they'll say, it doesn't line up with my Revit file.
Or in this case here, they don't really have one, and they'll say, it looks kind of weird. It's kind of at an angle. I can't really work with this very well.
That's not how I want it shown up on my sheet.
Yeah, so in this situation, we would just orient it, rotate it, basically, just so that way you have more 90-degree angles, which are easier to work with in Revit. And in this case, as I said, it's easier. It's just simple. You don't have to do origin to origin. You can just do center to center. But if you say have an existing Revit model, you have to set that origin. And this is something what they'll do is our customers will say, hey, can you line it up for us? We'll say, sure. They'll send us their Revit model. They're still working on it though. They're still working on their model while we're trying to line it up. So we're just gonna try to set that origin, and instead of sending that Revit model back, we'll just send them the scan file. So when they do origin to origin, it will land right where we want it to be. And we have two methods of doing this. We have the Revit, where we can measure how far it is and rotate and put those distances and rotations into recap, and it will do it. Or we use Navisworks, dragging the scan file around, line it up with the model, and Navisworks will actually save how far it's moved and how far it's rotated. We take that data and put it into recap. I recommend the Navisworks method for this personally.
All right, so when you get a point cloud, either you're doing it from, let's say you got an internal team scanning for you, or a third party like Kelar Pacific, you want to check their work. You need to, sometimes we have thousands of projects where we have literally thousands of scans. And so even as good as, Arian is in his job, every now and then somebody makes a mistake.
Yeah,
and one little wall might be slightly off. And so you need to double check your point clouds that you receive. How do you do that?
Well, there's multiple ways you can use. You can use Revit, you can use Recap, those tools, just using section boxes and top-down views and figure it out. Or you can do the method I personally prefer, which is Navisworks, which is using the section tool. And I'll actually show you how, if you've never used Navisworks before, this will be pretty useful. We use Navisworks a lot for mainly, I think, coordination, but it works great for this as well. And let me just get, here we are.
Hey
Okay.
guys,
Yeah,
I'm
you-
getting some feedback that some people are having trouble hearing you guys. Like when you switch computers, it became quieter. Is there any way you
Oh.
can turn up the gain on your mic? I don't know what the
Sure,
setup
sure.
is.
Can do. How about that? How's that?
That's much better. Thank you.
Okay, I think what I might be doing is suppressing. Yeah. How about, okay, that might be better. I think it was the background noise suppression might have been getting in the way.
Okay.
Let's see here. I'm going to share the screen. I think I can just share. There you go. Can you see my mouse?
Yep.
Good.
Yes.
Making sure. Hold this for me. All right. So right here we're in Navisworks and we have one of our buildings. So you can see it's modeled and it actually has some scan file with it, right? So what we're going to do is we're going to, can I move this control panel here? Yeah. Okay, good. All right, it's getting in my way. We can go to sectioning tools. Or yes. We're gonna turn on two planes and we're gonna link them. By linking them, when we move one of them, we can move both of them. And this will allow us to easily see how the scan looks. So if I go from a top-down view, right, we can now drag and we can see how it looks from each floor. We can see, okay, so there's some little like floaty bits. These are reflections, nothing to worry about. It is a laser after all, so mirrors and reflective surfaces can cause problems, but it's usually pretty good at making sure that being like, oh yeah, no, that's obviously a mirror. We're gonna try to get rid of it. But there is some cleanup work that's necessary. You can see we have some rooms that weren't modeled or incorrectly modeled compared to what was actually scanned. In this case, it's most likely the model is incorrect. This project was meant to be a, what was it? Help me out here, Chuck. What was this kind of project where we scan and then we're just verifying the existing model that we have?
Yeah, so we were hired to scan and then create a construction model. And what they also wanted us to compare the design, the architects, the design team's model to what was actually scanned. So what you're seeing, we're actually created a report and we're going to show you the report that we created in PDF that we basically highlight. We want to make sure that all of the structural elements actually line up. All the walls are correct. That way, then when the construction team starts their coordination process, they know it's actually correct.
I'll show you what the PDF looks like.
All right, let's move on. Let's get back to PowerPoint.
PowerPoint, I'm having a hard time. There it is. Yep. I have to present view. Hold on. I'm just trying to find all the buttons here.
Ben, can you guys see your screen?
Nope.
Yes.
Nope,
I'm
here we
seeing
go.
the AutoCAD. Yeah.
There you go. How's that?
Oh, there you go. Now we're seeing PowerPoint. And just I'm going to keep being audio police and talk as loud as you guys
Thank
can.
you so much. It's really helpful.
All right, the next topic is point clouds in Revit. It's the performance. Like these are huge files. How do you actually manage?
So when we want to, so a lot of these, some of these files can get, of course, the bigger the project, the bigger the file is going to be. The more complex the project, the bigger the file is going to be. The more scans you have to take, the bigger the file is going to be. And the bigger the file, the slower it may be in Revit. This depends, of course, on your computer specs, your hard drive. Are you using an SSD or an HDD? If you're using an SSD, it's going to be a little better. If you're working off of local, it's best because then you're getting the fastest connection as possible. This also depends on Revit. Also requires your CPU, your GPU, and if you're using Recap, you're going to have to worry about your RAM usage as well, which I believe you also have to worry about in Revit. So the more RAM you have, the better your graphics card, the better CPU, the better that's going to be. Of course, also the newest versions of Revit are faster. We found that between 2019 and 2020, there was a significant difference in how big a scan file can be before it starts to slow down your computer. We've done it where I think a 10 to 15 gigabyte works actually great in 2020, where in 2019 it actually struggles a bit. And I'll show you how we try to help break up that issue. When you export from an RCP to an RCS, a lot of times your scans, if they overlap, which they should, at least there should be at least a 33% overlap, you'll scan the same location a few times. And when you convert into an RCS, they'll actually compress it, be like, okay, well, there's 5 points in this exact location. We're gonna only have show 1. And that will reduce the size right there. But we can take this a step further. If I can show you how we do that in Recap. And bear with me here as I quickly and effortlessly try to switch from that to that. Hold on. Share screens. There we go. I believe this is our. Here we go. Here's our Recap. So here we're in Recap Pro. This is, you might be wondering, where's the building? This is because we actually have the building hidden away in a group here. Here we have the level 1. We decided with this building, it's the same building as before. We figured the best thing for us to do to really shrink this file down is to section it off based off level by level. So we have the level 3, which also includes the roof, and then we have level 2 and level 1. So when we do this, we just show basically like this, turn these off, and we have our level 1 building. And then from here, what we can do, we just go here, export this out, and it will export solely what you see on screen. So this will reduce the file size significantly from like 30 to a 7, but you only have 1/3 of it, you know? So you might be wondering then, well, how does it then line up properly? Because we set the origin, every scan, when we import it in, will fall right where it's supposed to be when you do origin to origin. It will fall right as it's supposed to be because they're all using the exact same origin. All right, let's head back into here. I'm getting the swing of switching from something to something. There you go.
Yes, sure. All right, so we want to show you a couple of projects, some videos that we created, and then we're going to jump out and to our actual project. All right, here we go.
We'll let the Bizot handle that.
All right, so this is a house, just a custom house. This is in Del Mar. The architect didn't have any drawings. They were going to do a major remodel. They were going to put I think an elevator in this house and redo the kitchen. So we went out and we scanned it. You can see it's a black and white scan. So we actually scanned it in about 6 hours, and then we converted it to Revit, and then created sheets for the architect as a starting point for her remodel.
Yeah, we could show you. We can do the sheets. We'll show you here in a sec. What's nice is we did in black and white because we weren't looking for an insane level of detail. We weren't doing anything involving pipes or electrical or duct work or anything like that. So we figured black and white, get it done quick, get it done out of the way, keep the file size small, because obviously adding color will increase the size of your file as well. So if I skip ahead here, I can show you the sheets that we took. So, right here we go. So yeah, and here's the sheets we made, and you can even have the scan in the sheets if you so choose, but that's up to you, whether you want them or not. Here we have the elevations as well. And there we go. Then here we have this underground, I don't know exactly.
Well, this is more of a
MEP.
MEP type project. This is a 640-foot underground tunnel between a main hospital and the central plant. The engineer actually hired us to, basically they were after these pipe racks on the right of this tunnel because they were going to have to route new things through it. So we scanned part of the project in color and black and white. So you can actually mix color and black and white to have a combination. You can see that where the spheres are, that's where our scanner head location was. Why are we mixing the elevations? The reason is because we want to get great coverage of those pipes. And the reason why is because we're going to take our point cloud and put it into Clear Edge 3D Edgewise. And it's going to automatically extract those pipes. In order to do that successfully, you got to have at least like 33% coverage.
33, but 66 is preferable. The more coverage, the better. This is, yeah. So, and you can see there was a lot of pipes here. And once again, the color is best so that way we know what kind of pipe it is. And I believe you said there's something else about this.
All right, so this is Edgewise.
Yeah, here's that.
here's edgewise. So, you know, if you scan properly and then you set the project up properly in edgewise, then we turn the computer on, let it do its work. It created all these pipes in about 2 hours.
Yeah, so it's good. If you can set it all up before the end of your day, just, you know, let it run, go home, come back next morning and everything will be done, taken care of for you. Or go to lunch, come back, you know. So if you ever need a little break, problem solved. And then we brought it into Revit, and I believe there was another thing mentioned you told me
So
about.
one of the things that we did, actually, the customer didn't ask us to do this, but we poked all the pipes insulation and we measured the thickness of it. So then we actually created a Revit insulation family around the actual diameters of the pipes underneath. They also didn't ask us to put them on the right family, the system. So because we scanned in color, we could see the labels of all of the pipes, whether it was hot water, cold water, exhaust, whatever.
Let me tell you, it was hot down there. So there was probably a lot of hot water going through. It was one of the ones I had to scan. So I think in the video you showed you how the installation looks. I want to skip ahead to that. There you go, right there. Oh, there it is. There you go. There you go. You take it. You can hear. You can see the. I believe the inside of the circle is the actual pipe, and the outside is the insulation. If I remember correctly.
All right, next one. So this is an above the ceiling scan is what we're really after. The structural engineer was going to do a ceiling retrofit. It's a really old school up in LA. So we weren't going to be modeling MEP, although we did a little bit here, but everything, I mean, this was pretty open space above the ceiling. This ceiling was a hard lid ceiling. These weren't axe ceilings, and they had a certain amount of access hatches already available for us to scan. We looked at like a really old above the ceiling drawings, figured out kind of roughly where the MEP systems were, and we directed the school district where they needed to cut additional hatches, access hatches.
You can see this is also in recap, where you can also, as I said, use as a viewing tool, which is great because it actually does a pretty good job with measuring. And yeah, so I remember we had to, there was a few access hatches when you get there, obviously not some being an old building, some of the, when they added new stuff into it, you have access hatches that just don't work because there's a duct there or a pipe in the way. But luckily, since we had asked them to put in multiple new areas, we were able to get a much better coverage of the above the ceiling area. So that way they can better easily see where pipes and stuff are for modeling.
So the engineer was really after all of the suspension wires.
Yeah.
So you saw in the scan that, you know, those wires were actually, they showed up, and we were able to model them in Revit as a starting point.
Mhm.
All right.
So this one here, these were, so the city owner asked us to verify the height of their parking structures. Now, you know, when you enter a parking structure and there's a sign there that says maximum height of vehicle 6'7", 6'8", or something like that. Well, we were able to do that with the LiDAR scanner, and we're able to do that without actually having to create a Revit model. We simply just took the scan, put it into Revit, and then cut sections. We just used the section tool to get different views, made them very thin, so that way we see just to the fine points, and it looks like this. And we just measured everywhere. And while we're on site, we're obviously looking and being like, hey, I think this area is a little shorter than others. And some of them will obviously surprise us, be like, oh, that was 8 foot all along. Some areas you'll find there's like 6 foot, there's like the 6'8" areas, 6'7" areas. And those are what we say, hey, customer, here's the lowest point, 6'9". And we didn't even model anything. This was just a scan, put into Revit, cut sections, and just investigate.
All right, last video, probably one of our larger projects, an entire high school up in LA. So we actually LiDAR scanned the interiors, and we used a drone to capture the exteriors and the roofs. They weren't really going to be doing anything different on the exteriors or the roofs. So they're mainly after the accuracy level inside.
So that let us use the 2 centimeter range of the 2 centimeter error range of the drone, which is what we use to get the roof.
So you also see a civil file here. We actually, the architect that hired us wanted us to geolocate all of the buildings in reference to the survey points. So we actually did that. We would scan in order to like link up survey data to your Revit models and your point clouds. You've got to scan that point outside the building and kind of make your way into the building, and then it automatically links everything up.
Well,
All right.
yeah, and later on, you're able to input that data into the scan files directly. So when you get them, you'll have them.
All right, so now we're going to go to the live demo. And why don't we give
All right. We're gonna jump on the Revit.
Can you see the screen?
Can you guys see the screen?
It might not be able to. 'Cause
Yeah,
that's-
it's gonna be.
Not yet.
No.
Go to share screen,
Yeah, I'm gonna do that. Just a moment.
and then yeah, that one. Click that. Oh yeah. Or no, that's fine. That's fine. No, that one's better.
Okay. Now what you're seeing, it's the and one of the
Yep,
power.
we got it now.
You can see it right now.
Yep.
So that's the same power, a continuation of the tunnel that you saw. The tunnel coming this way and end up to the mechanical, big mechanical room. And what you see here, that's a scan that we did for mechanical. I'm gonna grab a piece of this mechanical room and then make it as a section box. You guys are familiar, if you're working in Revit, you can create a section box. And what you see here, the goal of this project was identify the elements and actually model exactly the elements that we have there. And you see that even we modeled the boiler system and then plumbing and then all the plumbing. When I select any of those, you see, I just selected inside the pipe inside, because we basically use this gauge to define the thickness of the installation. That's why you're seeing the difference between my cursor and the surface is just the installation. And we've been able to deliver this file to even the hangers and so on. So you see the hangers is right at the scans and seismic bracing and so on. Why I show you this? Because this is based on the level of the detail you are expecting. We can provide not only the scan can be adjusted, what type of a scan we need to know, what the density and what the color and the black and white, or as well as we identify what objects is necessary to model. You see here, you even go to the 1/2 inch, 1.5 inch, actually it's a 1.5 inch diameter of the conduit and the boxes, and even the box holders and the unit struts that hold in the boxes. So in general, we need you guys, when you submitted any request for scanning, you guys get the idea what it need to be modeled. So I'm gonna go back to other areas. If you, I can cut the sections and go forward. You see here in the outside areas, we even model the tanks and so on. That's a continuation of the same model that we look at it. And then I'm gonna jump to the tunnel that we talk about in here. In a movie, I grab a piece of the tunnel and make it as a section box, basically by clicking that. That's a new feature they added in 2019 and 18, and it's great. And yeah, that's what you see here, right? All the pipes in here, and you see how the Revit react when I try to rotate for generating the model. It is in 2019 right now. using 2019. But if you're using 2020 and 21, it's going to be much easier and faster. That's a detail. Okay. All right. I'm going to switch to give it to the other people. Also.
All right. Back into our PowerPoint. There we go. Bam. Share. Bam. There you go. Okay. Oops. Hold on. Click there. There you go. Hit. Right.
All right, so frequently asked questions after, usually after we show some people the capability, the two most frequently asked questions are, how much does it cost? How long does it take? Basically, we need to figure out two things. How long is it going to take us to scan? Because we have a fee for per day for 8 hours of scanning. Our average cost for that is $3,000. Then we need to know what we're modeling. So let's talk about how we break that down. So we want to look at your building. You know, if you give us an address, what's the square footage? Smaller is typically easier. We can typically do about 200 black and white scans a day, or 100 color scans. So really, the question is, how many scans does it take to complete your building and what you want? If you've got existing old floor plans, we can kind of figure out. All right, you can see the floor plan on the bottom right. Each one of those blue dots is where we think we need to have a scan.
And there's so many because of how many rooms there are in this situation. The more rooms there are, the more scans we're going to need to take, because there's more corners we have to deal with. There's more doorways we have to deal with. Remember when I said earlier, I mentioned the 33% overlap. That's where the requirement for more scans and smaller, and when there's more rooms comes from. I do one outside the doorway, one inside the door frame, and one on the other side of the door, just so you can maintain that overlap, so that way the scans can connect to each other. Otherwise, you're going to have issues later on in the stitching process, and even miss a few things when it comes to modeling.
Right, so is black and white good enough for you, or do you need color, exterior, interior? And then, I mean, I think a real big difference is it below the ceiling or above the ceiling? If it's above the ceiling, is it a T-bar where we can move the act tile, or is it hard lid? And are there access panels? You know,
are the access panels good? We've had it where we've opened them up and there's just something in the way that we can't use it.
All right. Next part is, if you want to convert that to a model, maybe you know how to convert a point cloud to a model. If you don't, there's people that really are good at it. It'll save a lot of time and cost a lot less money. So what needs to be modeled? Because there's a lot of things. Look over on the right-hand side. There's an Excel spreadsheet that we typically hand to clients and say, okay, here's your menu of elements. What do you want modeled? And then at what level of detail? You know, we're using the BIM forum, LOD scale, 100, 200, 300, 350, 400. So all of those things make a difference. Is it just the architectural elements, walls, windows, doors, casework, countertops, and soffits, or you want,
pipes, outlets, stuff like that? Again, it's important because that will mean we have to do higher resolutions, make sure we do it in color, make sure we capture those. These are important things that we need to know beforehand. Otherwise, we're going to have to go back on the site, rescan, and then come back just to make sure you're satisfied. We want to make sure we give you the scan file one time and that you're satisfied with that.
Seems like every project's different. So it's just best to kind of go over each project detail, and then we can create a proposal, or any other service provider should be asking the same question.
Yes.
All right. So here's the key points that we think I wanted you to walk away with today. Is that there's reality capture methods, that can create as-built data. There's multiple kinds. LiDAR scanning is the most accurate. It's very accurate. Plus or minus 2 millimeters. I mean, normally if your care of service for an architect is 1/8 of an inch, you need this kind of accuracy. There's multiple scanning file types that will be a deliverable. There's a viewing file and then a point cloud file. And we talked about the two file types, an RCS and an RCP. Those are the ones that you're going to deal with in Revit and AutoCAD.
These point clouds are large.
They're huge. Make sure you have the storage space for them. Well, I mean, depends on the size of the project. If you're doing something like a house, shouldn't be a problem. But if you're doing something like a whole hospital or a school, then we're talking larger file sizes, especially depends also which scanner you're using. Some of them are larger than others. So, but you have to make sure you're able to, one, have the computers to handle them. And generally any modern computer should be able to handle them just fine.
Yeah, I've heard multiple stories where customers, they've received point clouds, but they say they can't use it because it's not lined up properly. It's not oriented. So, work with your service provider or your internal team that knows how to scan, line it up properly.
And if you're looking for a scan file to use in CAD, you're going to need something really small, not very dense. CAD doesn't do very well with scan files, but Revit is more capable of handling.
Last thing, scanning cost depends on a lot of project variables, the size and the complexity. Just think about the average 200 black and white scans for 8 hours and 100 in color same time. And that's all under the ceiling. If it's above the ceiling, probably cut in half to a third.
Yeah.
All right, Ben, that's it. I don't know if anybody has if you guys want to turn on the people's mics or there's questions in the Q&A pane.
Yeah, I think people can unmute themselves. If you guys have any questions, you can put them in the chat or raise them now, but see if we got anything. Otherwise, thank you guys for a very thorough presentation. I learned a lot.
Yeah, there's a lot to cover.
Yeah.
And we had a couple of technical difficulties, but
Yeah, we gotta work that.
Yeah. I don't know, with your mic trouble, I'm not hiring you guys for sonar, just for LiDAR.
I'll make sure to bring about my more professional microphone next time.
All right. I don't think we have any. It says Brian wants to know, does Kelar provide this kind of service nationwide, or is this a San Diego thing?
Nationwide, our scanners are actually, they fit into backpacks. So we've scanned in Florida, New York, Texas, Northern California. Yeah, we're nationwide.
Yeah, wherever you need us to go, we'll go.
All right. We'll give people one more chance to say anything. Otherwise, once again, thank you guys. Really appreciate everything, everything you went over today. And MJ, we recorded this, and we will be providing we'll posting the recording to the AIA website. Is that correct?
Yes, I will get it edited at the beginning, and then we'll post it on the YouTube channel. So just stay put for our YouTube channel because we're there. I can put the link down here if anyone's interested in following.